So welcome to part 5 of our electrophilic addition to alkenes series. In this video, we're going to talk about um, syn and anti-addition. So it's easiest to see when you have a ring when syn and anti-addition occurs, but you don't need a ring necessarily for it to happen. And for syn and anti-addition, basically, syn addition means you add to the same side. So if I added x and y, and I did a syn addition, we would get x here and y here. Or I could have had both of those as dashes. So syn just means we added both pieces to the same side or same face of the double bond. Whereas an anti-addition would be adding to opposite sides. So you might add the x as a wedge and the y as a dash. That would be an anti-addition. Now, a lot of times, syn and anti-addition isn't that important because if you have something like this, and I added syn or anti to that double bond, this will result in a achiral center. So I would get, let's say, a bromine here and a bromine here. This is not chiral, so it doesn't matter if I added syn or anti. There's no chirality there, nothing that we'd have to distinguish between diastereomers. But if you had a chiral center there, now you would have to pay attention to the fact of whether or not that's a syn or anti-addition. So really the only time it matters is when you have two chiral centers as a result of the addition process. Um, and the way the mechanism works for syn and anti-addition is a syn addition is usually a concerted process, whereas an anti-addition is going to be a stepwise process. So if we look at that, a syn concerted process would be something like this. If I have a double bond here and I add X, and during that process, that mechanism, I'm basically adding X, or let me see this here. I am adding X all at the same time because those have to be on the same side as the reaction occurs for it to be concerted. And so when that happens, I would get both wedges or both dashes. Now, if I do a stepwise process, for example, I form a ring. I would add that ring as either a dash or a wedge. I don't know which one it would be. It could be actually both. And now when I add my x minus, I should have given myself more room here. Let's add x minus. That x minus is going to add, but it cannot add to the same side. That initial x that added is a wedge. It is taking up all the space above that ring. So the second x must add as a dash. Concerted process. Therefore, we're going to get an opposite or an anti-addition. Now, the other type of process is when can you get both syn and anti? Notice in these, we did not form a carbocation. So when you don't form a carbocation, it's either going to add a syn or an anti, one or the other. Depending on what X is, it's either going to add to the same side or opposite sides. If you form a carbocation in the process, like if we add HX, now we still have a flat or planar carbon here. The carbocation is planar, and regardless of how this first X added, if it added, or sorry, that's not the X, the hydrogen adds first. Regardless of how that hydrogen added, if it added as a wedge, The X could either add as a wedge as well or a dash because this carbon right here is a planar carbon, an sp2 carbon, and we cannot control where the next thing adds. Whereas when we form a ring, like over here, we cannot add to the same side as X because it's taking up that wedge space on both carbons. So the addition has to happen from the dash side. Over here, however, the carbon we're adding to doesn't have something above or below. It's a planar carbon. So we can add it either above or below. So whenever you add concerted, you're going to get a syn addition. Whenever you added the stepwise without a carbocation, we're going to get an anti addition. And whenever you form a carbocation, you're going to get a mixture of both. So if you make flashcards, what I like to do is typically write out a reaction. We're going to learn the general reactions later, but you'd have a reaction. And you might have, let's say, something like this. And I'm going to add HX, and maybe your flashcard is predicting the product. So on the back of the card, you'd have the product, which might be something like this. And what you could do is on the flashcard, write something like this reagent is Markov-Nikov addition. It is going to have rearrangement because it goes through a carbocation. And that reagent is also going to be both a syn and anti addition because it goes through a carbocation. So when you do your flashcards, don't just have starting material, product, reagent. Also on the flashcard, write down some key aspects of the reagent. Maybe have flashcards of reagents. Just have a reagent and state whether it is Markov-Nikov, anti-Markov-Nikov, whether it's a syn addition, anti addition, whether it could do rearrangement or not. And again, I'll talk about that more in the next part when we look at specific reactions.